So I'm going to talk about proof of stake and the staking economy. And yeah, I'm really excited for that. So just a little bit about myself. So I've been working in crypto since 2013, almost 11 years now. I've also been involved in kind of the proof of stake world for a long time. So in 2017, I joined this project called Tendermint. I was the first non-developer there and was chief operating officer there. Of course, Tendermint is the company that created the Cosmos ecosystems, out of Cosmos ecosystem. And then soon after I started Chorus One, and as a sort of one of the first staking companies. Aside from Chorus One, I'm also still very involved in the Cosmos ecosystem in other ways. So I'm on the board or the president of the Interchain Foundation, which is sort of the original Cosmos Foundation that did the Atom fundraiser and sort of funds most of the Cosmos core development. And I've also started, one of the early things I did when I got into crypto, I started this podcast called Epicenter. And we have done, it's now the longest running crypto podcast, also over 10 years. And we've done, I think, over 500 episodes, including with many of the speakers who have been on the agenda here. And then maybe one more thing I'm involved in, I'm also on the board of the Urbit Foundation. I'm pretty involved in the Urbit ecosystem. For those who are interested in that, I think there's a talk later by Thomas, who works for the Urbit Foundation. So you guys should check out that. So proof of stake. What's proof of stake? So proof of stake is basically a mechanism in blockchains to achieve agreement on the state of the network. So the validators are responsible for checking the transactions, for proposing blocks, and then for checking the validity of other people's blocks, and basically securing the network. And this idea has been around for a long time. Even when I got into crypto, the idea and the concept was already there, but it took quite a long time for this to, really break through. And of course, there's a lot of advantages. I'm going to speak a little bit more about the sort of advantages of proof of stake versus proof of work. But, on a high level, right, in proof of work, you're using hashing power to secure a chain, and that's very expensive. And in proof of stake, we can use collateral, we can use a crypto asset to secure a blockchain, and that's not very expensive, and also doesn't use a lot of energy. So there's a lot of advantages to that. So just a little bit about Chorus One. So we started in 2018. This was before the first modern proof of stake networks launched, like Cosmos, Tezos, Polkadot, etc. And today we run on around over 50 different networks. We have around 3.5 billion that's being staked with us. We are a team of around 65 people in all over the world, I think 24 different countries. And there's a few other things we do. So we do a lot of investments as well. So we've made around 60 different investments so far. And we have a big research focus, and I'm going to come back a little bit to some of those things later in the presentation. And, we've also been putting a lot of effort into our Ethereum product called Opus. But let's talk about proof of work versus proof of stake now. So just on a high level, right, if you zoom out here, so the proof of work market cap today is about 1.4 trillion. So that's around half of the entire crypto market cap. And basically almost all of that is Bitcoin, right? There's a few other small proof of work chains like, Dogecoin, Litecoin, things like that. But, they're really quite minuscule. And what we've seen over the last, 5+ years is that almost all of the new projects are proof of stake chains or sort of indirectly secured via proof of stake. So the market cap of the proof of stake assets today is around 770 billion. And if you look at, something like CoinGecko, CoinMarketCap, if you look at the top 10 assets, then I think currently around 8 of them are either proof of stake assets or they're secured primarily by proof of stake chains. So, even if you take something like USDT or USDC, right, these are mainly issued on proof of stake chains today. And so the proof of stake assets themselves make up around 35% of the total crypto market cap. And if you exclude Bitcoin, then proof of stake assets or assets secured by proof of stake chains make up, over 90% of the crypto market cap. So it's really become absolutely fundamental to how we secure blockchains and how we scale blockchains. If you look at this in terms of efficiency, I think that's also an interesting way to look at it, right? So Bitcoin has a market cap of 1.36 trillion, and every day it pays around 60 million to miners for securing the blockchain. So every year that amounts to $22 billion. So it's a massive amount. On the proof of stake market cap is around 770 billion, and around half of that is staked. And then every year the staking rewards for all of the people staking is around 18 billion. So it's just a little bit smaller in terms of rewards than what's going to the miners. But of course, there's a huge difference. In proof of stake, most of the rewards that are being paid, they go back to the token holders. So they're not really an expense in the same way that, paying miners is an expense. And if you assume something like 5% on average that commissions might be paid to the actual validators who do the work of running the infrastructure, that amounts to something like 900 million a year. So if you look at this in terms of efficiency, right, so we basically have Bitcoin, which is around twice as big as the proof of stake markets and spends around 30 times as much on security than the proof of stake market. So another way of putting it is proof of stake, just in terms of the cost, is around 15 times more efficient than proof of work. And I think in the future, this relationship might, proof of stake might become even more efficient in this way. And of course, that's just in terms of the cost. I think if you take it in terms of the energy usage, then the relationship is even much more extreme. I think I remember reading when Ethereum switched from proof of work to proof of stake, the sort of estimated energy consumption of the network went down by like 99.9%. So another massive difference, right, is in proof of stake, really the amount of parties that are involved is very large, right? So you have a lot of individuals here. I'm sure many of you are staking. You have foundations, teams, whales, you have wallets, you have exchanges, you have different institutions, you have things like ETFs. So there's really a vast variety of entities that can engage with crypto networks through staking, which again is very different from proof of work, right? Where it's basically, a small insulated industry or not so small insulated industry, but that's doing the mining, but, sort of normal people do not engage in this at all. Course one, we kind of cover all of this, right? So we work with all kinds of different parties, but we do have a bit of a focus on working with more institutional partners. So let's say we have around 337 billion that's being staked, and currently around 18% of that is through liquid staking, and the rest of that is through direct staking. And if you look at the staking rewards, right, these 18 billion I mentioned, then today around 15 billion is coming from inflation. So it's just new tokens that are being issued every block, every epoch. And around, we have 1.8 billion that's basically gas fees, MEV 800 million, and others 100 million. Now, on the right side, this gas fees and MEV is very Ethereum heavy, right? I think on most other chains, the vast majority of revenues comes from inflation, but there are exceptions. For example, this other bucket there, the 100 million, I think a large part of that is DYDX, right? Where trading fees are paid in USDC and they're paid to the people staking, and DYDX has no inflation of the native token. So I think that's around, 80 million a year. Now, I think if you think in the future, I would expect this chart to look quite different, right? I think as these networks mature, hopefully a lot more of the revenues are going to come from transaction fees, from MEV, or other types of revenues, and part of inflation is going to go down. Now, proof of stake, it's this umbrella term, but actually the way proof of stake work also differs a lot between different chains. So Ethereum being one example of this, right? In Ethereum, you don't have any in-protocol delegation. Every 32 ETH, you create a new validator. There can be an unlimited number of validators. And so that's kind of one model. But most of the proof of stake chains, they have in-protocol delegation. So you can create a transaction and you can delegate it to a validator, and you have a more limited validator set. Typical might be 100 validators, 50 validators, 200 validators. It depends a little bit. Some have higher too. I think Avalanche, Polkadot, some have higher validator numbers. and they generally have like a variable voting power, right? So like some validator will get lots of stake, and then they will produce many more blocks than the smaller validator. And yeah, that's basically the vast majority of proof of stake chains are here in this second category, although there are a few that have also copied the Ethereum approach. And so it also means the kind of types of staking solution, they vary a lot. So we have like the direct delegations, for example, we run white label validators for others. So like ZK Validator is one example on Cosmos, where we run the infrastructure, but it's sort of their brand, they do the governance. And key management can also be split, where maybe some party manages some keys and we manage some other keys. And of course, liquid staking is an important part as well. We've been very involved in liquid staking from a long time ago. We did, in 2019, build the first sort of liquid staking implementation for Cosmos in a hackathon, and then wrote this white paper about it. We were one of the Genesis validator of BUIDL, and also involved in a bunch of other liquid staking efforts. And then, you also have the more sort of institutional API type products that, will be integrated into, things like exchanges or wallets on the back end, so that people use that existing interface to stake. So here's a chart on liquid staking. As you can see on the left side here, we have on Ethereum is 43% is being liquid staked. So that's a very high percentage, and that has a lot to do with the staking design that Ethereum did, where it's basically pretty inconvenient to stake yourself. You cannot delegate to a validator. So, and of course, when Ethereum launched, you couldn't withdraw the ETH stake either. So you were kind of locked in for an indeterminate amount of time. You have to have 32 ETH at least. So as a result, we've really seen liquid staking have a very large market share. And Lido was early. Lido had a great product, and so they're really dominant there. On other proof of stake networks, I think all of them, the liquid staking portion is a lot lower. So this is an example of Solana, right, where we have around 5% or a bit more, almost 6% that's being liquid staked. And then, it depends a little bit whether you have like one winner being very dominant, or you have more of a market where there's different players. So for example, on Solana, you have two players that are around similar size. If you look at Cosmos, you also have like one Stride that's like pretty dominant. So it depends a bit on the different chain. And I guess it's still to be seen if in the long run, the equilibrium here will be a sort of, winner take all market, or if we will have stable equilibriums where there's a whole range of different liquid staking products. One thing maybe on our Ethereum product, actually, we work a lot, or we've been building a lot on Stakewise. So Stakewise is also interesting because Stakewise kind of allows you to do sort of a mix of the both, where one can stake with, let's say, Chorus 1, and there's a sort of a vault, a smart contract for Chorus 1, and then there will be other smart contracts for other operators that can, work a little bit differently. They have their own fees, their own structure. But all of these together can mint a liquid staking asset that's shared. So I think that's a quite interesting approach that sort of is a little bit of a hybrid between the direct delegation with a validator and liquid staking. So it's still pretty small, but I think Stakewise is a really elegant solution, and hopefully we'll see a lot more models like that in the future. So let's talk a little bit about MEV as well. So MEV is something that's became like really important. And MEV basically just refers to the ability of a validator, right? When a validator comes up, they create a block, they have some discretion on, what goes into the block and the order of the transactions into the block. And there's a lot of value in that. So the value can come from something like an arbitrage. Let's say you have a decentralized exchange and the coin is trading at a certain price and it's trading at a different price on a centralized exchange, then being the first party to do that trade on chain, there's value in that. And so that's arbitrage. But of course, we have other examples like sandwich attacks that probably people have also heard of that often will consider sort of like bad sources of MEV. And especially on Ethereum, MEV has become, very important where, practically all of the validators run some kind of MEV solution. And MEV, so on Ethereum, it kind of works. Ethereum has also done this thing where it's kind of split up a little bit how blocks are being created. So on Ethereum, in most other chains, basically it all goes to the validator. Transactions go to the validator. Validator creates a block, and that's kind of it, right? On Ethereum, we've had this breaking apart of this role into different parts. So we have a builder who really just creates the blocks, but they do not necessarily run validators. And we have a pretty small market of, I think, currently around 3 builders that are very dominant, and 2 of them are actually run by trading companies like Wintermute and another one. And then you have a relayer. So basically, the builder sends this block to the relayers. The relayers kind of sends it to the proposer, which means the validators, and then that's how this is being created. But there's a lot of discussion on Ethereum too, how this should evolve in the future. And it may well be that this is going to change how this works. And it's kind of unclear if this sort of model will be adopted by other chains as well, or if we will see different ways of handling MEV. So maybe also worth mentioning here that application-specific chains have a lot more flexibility in how they can handle MEV. So to give an example, Osmosis has a sort of in-protocol mechanism where the protocol tries to capture the MEV and then sort of distribute it back to the people staking, so that the validators really are not able to engage in MEV. And another example here is DYDX. We worked actually a lot with them on the MEV design for DYDX chain. And the way that works is that there's a sort of a rule for the network that validators should not do MEV, and then they basically do data analysis on what the blocks look like, and if a validator engages in MEV, they're subject to slashing. So I think application-specific chains can do these kind of things where they basically customize the way MEV is handled depending on the application. But that's not something that really works for generalized smart contract chains with all kinds of different applications. And I think there's a important long-term question is like, does MEV lead to centralization, and in what way? We have done a lot of work around MEV also on Ethereum, where we've sort of created a modified Ethereum client called Adagio that basically tries to optimize how MEV is done. So we basically measure a lot of data around how the network works and then try to optimize the kind of the quality of the blocks we get and how much they pay. And we've been tracking this data. So like in the last 30 days, we were able to earn around 12% more MEV, and since launch around 7.5%. And so we have a sort of quant research team that's been focusing on that, and a lot of other staking companies have started to sort of copy this approach or try to do something similar. And so like, of course, there's a lot of variance in this as well. But like, for example, if you look at the last 30 days, we were able to get like 4.46% versus like the sort of average of the institutional staking providers, which is like 3.87. So that kind of thing is possible on Ethereum now, although it takes a lot of work and sophistication. It's not really so much possible on the other networks because there just isn't much MEV. If people are interested, we published a kind of scientific paper on this as well. So if anybody wants to check it out, you can find it here, or there's a ETH research post where we wrote a bit on like how this works and the data analysis around it. So let's talk about another important trend in crypto, right, which is restaking. So restaking at the moment is a sort of, very hype, right, with eigenlayer. And on a high level, the idea is pretty simple, right? When you're staking tokens, then they're kind of locked up and you can't use them for much else. And that's not necessarily that efficient, right? Because it is maybe at risk of slashing, but the slashing penalties, there's not a lot of slashing, and even when there is slashing, generally only a very small percentage is being slashed. So for example, on Cosmos, it's often capped to 5%. Some chains have no slashing at all, like Solana. Others, it kind of varies, but like Ethereum, but it's still generally very low. And so, of course, the idea would be, well, we have all this value that's being locked up. Can we use that value to do additional things and to generate additional returns? An example of that that's live today is, interchain security in Cosmos, where basically the atoms and the Cosmos Hub are also used to secure other blockchains. And there are other examples of that, like Polkadot, for example, is also a model where, you have the dots and they are used to secure the other parachains and also increases sort of, the efficiency of the usage of that collateral. And of course, in EigenLayer at the moment, there's a lot of innovation and a lot of money has gone into that, but it's not live yet. But I think in the future, we will see a lot of protocols that are also leveraging staked ETH to secure additional services and to create additional returns. Of course, this comes with a lot of extra risk. But on the right hand here, you can see the sort of EigenLayer thing where you have staking. Generally, this is done by liquid staking, and then it's being restaked, and then securing additional services and generating additional returns. Now, another thing worth mentioning here is layer 2s, right? So layer 2s, they try to leverage the security of a base chain to kind of guarantee, the security of blockchains that are built on top of that. This is meant to, address scalability. So, for example, Ethereum has decided that they don't really want to scale much the base chain, the transaction throughput, but they want to scale through blockchains built on top, this kind of like layer 2 and rollups. Now, today, layer 2s tend to be very centralized. Generally you have like one, it's called a sequencer, that basically produces the blocks and orders the transactions, and you sort of rely on them. How much trust there is in that, it varies a bit. Often today it's pretty high, but in the future with different kinds of fraud proofs, that trust might be lower, but you still have the case that you're relying on central party. They could go down. And of course, there's also regulatory concerns where someone might say, well, this is actually not a decentralized network. So as a result of that, there's a lot of effort for layer 2s to decentralize the sequencing. So they basically want to say, hey, instead of having one server that does all that block reduction, we want to have, a whole number of different parties that do it. And the thing, when you do that, it sort of goes in a similar direction like proof of stake, right? So because now you have a whole bunch of different entities, and especially if you want to make this a permissionless system, well, maybe you need to have, first of all, you need to have some system for selecting who produces the block at a particular time. And then you may want to have some slashing, right? If they do something wrong, if they go down. And so I think what is probably also going to happen is that a lot of layer 2s, they introduce a staking-like mechanisms to ensure the decentralization and the reliability of these decentralized sequencer sets. And actually, we see in many of these decentralized sequencers then using, again, technologies that are coming from proof of stake, like, for example, Tendermint as a consensus, to basically, secure these decentralized sequencers. With zero-knowledge proofs is another sort of technology that's being used a lot or for this kind of thing. This is a big area of also innovation. It's very early with a lot of change happening here. But I think in the future, our expectation is that a lot of layer 2s will start to look a lot more like proof-of-stake networks today. One last thing I wanted to talk about is governance. So governance is something where, it depends a lot on the different networks, how that is handled. But in many proof-of-stake networks, the validators play an important role in governance as well. And the governance can have many different characters, right? You can have things like parameter changes. So let's say you want to change inflation, you want to change some like for example, or you want to change how incentives are distributed. Often this goes through governance. You can have things like proposals where someone says, hey, I don't know, like the wide range of stuff. Or you have often community pools that are being also deployed and controlled via token governance, or votes on software upgrades. So there's a wide variety of stuff that governance can handle. And in the Cosmos case, and it's also true for some other proof of stake networks, this is often tightly coupled with staking. So the quorums, so like on many Cosmos chains, for example, you need to have something like 33 or 40% of all of the staked assets have to participate in the governance for it to be a valid governance vote. And that has a lot of benefits over, for example, the DAO governance we see in Ethereum, where generally people don't really engage and only a very small percentage of the tokens end up voting. But here, because the way it works is that if you as an individual do not vote, then you kind of vote the same way as the validator. And so that leads us to having a lot of participation in governance and sort of a high security that some whale cannot come in and just change a governance vote. And it's also something we're very engaged in. So we did this report last year and we voted over the entire year in 1,246 governance proposals. So, it's like 4 proposals a day almost that on average that we were voting on. So really a massive volume of activity that's happening there. It's also something we track, right, where we basically try to benchmark against other validators and, try to add a lot of value to networks by being really active and helping proof of stake networks come to decisions. So, if you're interested in that, there's also a report we did on sort of the state of governance in Cosmos networks, where I think we see the most governance activity. So that's it basically. So to summarize, I think proof of stake has become one of the largest sort of on-chain industries, right? I mean, of course, the largest crypto industry is trading on centralized exchanges, but I think when it comes to actual native crypto industries, proof of stake is one of the largest industries today, with a huge amount of parties participating, a huge amount of value at stake, and playing a crucial role in securing decentralized networks. And it's a very exciting space. So thanks so much. And if you have any questions, feel free to reach out.